Hello everyone, I'm Ziwen from Chemical Engineering Department, and today I would like to introduce some recent progress of the artificial skin. As the largest organ in the human body, the skin plays an important role in our daily life. The powerful sensing system of the skin can help the human body sense pressure, deformation, temperature, humidity, and other stimuli, and transmit these changes to the brain in the form of different electrical signals. And the human body relies on the sensory inputs from skin and the proprioception of muscles, tendons, joints, and other motor organs in different states to maintain normal posture and complete the basic activities of our daily life. Artificial skin is a flexible electronic device that stimulates the human skin sensing mechanism by converting physiological signals into electronic signals. Based on the mechanisms of the mechanical to electrical signal conversion, we can further classify the artificial skin into the types of resistive, capacitive, piezoelectric, and triboelectric based devices. And among them, capacitive mode artificial skin has become popular due to its simple device structure, lower noise, and good static mechanical load response. And conventional capacitive mode artificial skin often consists of electrically conductive electrodes and dielectric layer. And the capacitive results would rise along with the induced change of the separation distance under a pressure load. However, the limited permittivity of the dielectric layer and the restricted physical separation distance makes the capacitive values to be measured on the order of tens to hundreds of picofarad per square centimeter, and which is highly subject to parasitic charges and environmental electromagnetic noises. And to solve this problem about the new modality known as interfacial supercapacitive sensing or ionic sensing, utilizing the supercapacitive nature of the electrical double layer occurred between the electrolyte and electrode interface, was originally proposed and demonstrated by the researcher in 2011. And this device exhibited ultra-high unit area capacitance, which were on the order of 0 microfarads per square centimeter, more than 1,000 times greater than that of the conventional parallel plate capacitive sensors. And the significantly improved unit area capacitance of the sensing interface was then directly correlated to the detection resolution, as well as the overall device sensitivity. In particular, both the parasitic influence and the electromagnetic noises from the environment became negligible. Moreover, it also offered high noise immunity, high spectral definition, and response to both static and dynamic stimuli. And since then, development of the electronic sensing had been accelerated. And in the last decade, engineering the electrolyte layer with microstructures such as hemispheres, pyramids, concave pillars, cones, random bulbs, and graded interfillable architecture has shown great promise in elevating the sensitivity of the ionic skin. And this microstructure will cause the air gap between the electrolyte and electrode, and then the air gap lowers the overall structure stiffness, allowing for more thickness reduction at the same pressure compared with its bulk counterpart. And secondly, the initial capacitance of the ionic skin will also diminish owing to the presence of an air gap, which amplifies the relative capacitance change. we have discussed and summarized the progress of the artificial skin and the future research and development of the ionic sensing technology may focus on utilizing a distinct properties and characteristics offered by the remarkable interfacial sensing mechanism. As we know, most biological materials are intrinsically ionic, and therefore the natural materials can be utilized as a part of the electronic device architecture. And it has been demonstrated previously in an epidermal electronic device. And further studies utilizing its intrinsic biocompatibility are expected to drive the research toward more medical and healthcare directions through various means, and such as wearable, implantable, or digestible formats. And this is all my presentation. Thank you for listening.